So there is a very interesting update looking into this vlang code again. So it's profiling to figure out where the delta is coming from. So one is the HTTP stack. The second is your struct and the JSON encoder. Third is the HTML library built-in, which I was using to extract hrefs out of link anchor elements, right? The HTTP stack still doesn't seem to be something that I can go over and beyond to optimize further, because it's a couple of levels of abstraction on top of your base sockets and everything. Unlike the C code, which is a pure first level abstraction on top of sockets, which is libcurl, right? Now, what I've done here is to introduce regex, use a rudimentary regex in some sense to identify link elements and the links out of them, right? So if you look at it, the original code would have had the net.html package. Now I've replaced it with the regex and I'm using the regex here, right? And this is a watcher script that is running here that compiles and runs it again when there is a change in the file, basically when the file is saved. So I'm saving the file. This is the last run that I ran, which is 1.6 seconds to fetch the content and then get the links out of it, right? In comparison, my C pipeline right now is around 0.8 seconds on this machine at the moment. So let me try it again now. Let's see how it goes. And it's building. Compiled. Compilation still is slow. Anyway, going back here, right? It is taking an average of 1.6 seconds. And if I look at the C pipeline timelines now, it is about a second. On a good day, it will probably be around 0.8 seconds, right? As you see, it still is slower than C. The next operation that I would probably be looking at is to drop the JSON encoder completely and hand roll the JSON string as it were, like how I'm doing in the C. Now the thing is here, there are no further additional changes in the build pipeline. It is a standard production build that the V compiler by default does, which is, if you look at it, it is an O3 flag by default internally. When you do a dash prod on the V compiler, V file.v and dash prod, it internally passes on the O3 flag to the underlying toolchain, which is CC. The base compiler that it uses is CC, but there is a flag, if I remember right, it's dash CC, which allows you to provide the compiler toolchain itself. I can check that. Let me check this once. Make file, right? So yeah, this is the flag. So the dash CC allows you to provide the compiler toolchain that you would want to use while generating, rather compiling the generated C files into a binary finally. And this additional C flag that I'm using are for minor optimizations, and prod will add an O3. So this is how this makefile is set up right now, from which I'm able to get it all the way till about 1.66 seconds. So this is a first level improvement on top of the previous number that I was looking at earlier, wherein the numbers were almost 2x. If I were to be honest, it is still 2x, but the numbers have come down significantly. For multiple URLs, I have not tested this. I would probably have to check that next, in the sense that, is this bottleneck still coming from the sync.pool, where it is not a true threaded operation like how you would be expecting in the C pipeline, the C code, right? That is another one. So there are two optimizations still left in this entire operation. One is the sync pool optimization and the JSON encoding optimization, which would probably be V2 to see whether we can still push it further and get to a point where we take back our steps. Basically, I am biting the frog, so to speak. That also begs the question, do we need the struct here in this kind of a manner? Is there a better way to do it as a C binding, like how, say, your Python allows it? Rust allows interoperability via C code being embedded in. So is there an option? So that is the V3 probably is what I'm looking at the moment. Peace out.